Welcome to the world of generative AI. In this comprehensive crash course, we will embark on an exciting journey into the realm of artificial intelligence that enables machines to generate new and original content across various domains. Generative AI has revolutionized creative expression, content generation, and data augmentation, opening up endless possibilities for innovation and exploration. Hi, I am Vivian Arana, and I will be walking you through this course to the best of my ability. Generative AI refers to a class of algorithms designed to create new data that resembles the patterns and characteristics of the input data it was trained on. Whether it's generating realistic images, composing music, or writing text, generative AI allows machines to exhibit creative and produce content that is indistinguishable from human generated content. Through the use of deep learning techniques and neural networks, generative models learn to understand the underlying structure of the data and generate new samples that exhibit similar properties. Our journey begins with an introduction to the fundamentals of generative AI. We'll explore the different types of generative models, including generative adversarial networks (GANs), variational autoencoders (VAEs), and recurrent neural networks (RNNs), and transformers. Understanding the principles behind each type of generative model will lay the foundation for further exploration and experimentation. As we delve deeper into the world of generative AI, we'll discover its wide range of applications across various domains, from generating realistic images and synthesizing music to creating lifelike characters and virtual environments. Generative AI is transforming industries and enabling new forms of artistic expression and storytelling. We'll explore real world examples and case studies to understand how generative AI is being used to solve complex problems and drive innovation. However, with great power comes great responsibility. Generative AI also presents unique challenges and ethical considerations that must be addressed. From mode collapse and training instability to concerns about the misuse of AI generated content for malicious purposes. Navigating these challenges requires careful consideration and ethical decision making. We will discuss strategies for mitigating these challenges and prompting and promoting responsible AI development practices. To embark on this journey, it's essential to equip ourselves with the right tools and knowledge. We'll explore popular deep learning frameworks like TensorFlow and PyTorch, as well as specialized libraries like GANLib and pre-trained models like OpenAI's GPT series. Through hands on experimentation and exploration, we'll gain practical experience and develop the skills needed to build and train our own generative AI models. Whether you're a seasoned AI practitioner or a curious beginner, this crash course will provide you with the knowledge, tools, and resources you will need to dive into fascinating world of generative AI. So let's embark on this journey together and unlock the boundless potential of AI driven creativity and innovation. Welcome to the world of generative AI. Introduction to generative AI. Let's go over the definition overview. Generative AI encompasses a class of algorithms designed to create new data that is similar to the data it was trained on. Unlike traditional AI systems that are task specific, generative models have the ability to generate novel content across various domains such as images, text, music, and videos. By learning the underlying patterns and structures of the input data, generative AI algorithms can produce outputs that exhibit similar characteristics. Importance and applications. Generative AI has revolutionized many industries and opened up new possibilities in creative expression, content generation, and data augmentation. Some key applications include art and design, generating images, graphics, and animations for digital art and design projects. Content creation, automatically generating text for articles, stories, or social media posts. entertainment, creating music, videos, and visual effects for movies, games, and multimedia experiences. Data augmentation, generating synthetic data to augment training data sets for machine learning models, improving performance and generalization. Personalization, generating personalized recommendations, product designs, or marketing content tailored to individual preferences. Generative AI not only enables automation and efficiency, but also sparks creativity and innovation by providing tools for exploring new ideas and possibilities in various domains. As the field continues to advance, the potential for generative AI to impact diverse industries and enhance human creativity is virtually limitless. Types of generative AI. The first one that we'll look at is generative adversarial networks, GANs. Generative adversarial networks are a class of generative models introduced by Ian Goodfellow and his colleagues in 2014. GANs consist of two neural networks, a generator and a discriminator. The generator attempts to generate realistic data samples from random noise, which, while the discriminator aims to differentiate between the real data samples from the training set and fake samples generated by the generator. Through adversarial training, where the generator and discriminator compete against each other, GANs learn to generate increasingly realistic samples. GANs have been successfully applied to various tasks such as image generation, image to image translation, style transfer, and super resolution. Next, variational autoencoders or VAEs. VAEs are another type of generative model that learn to represent data in a lower dimensional latent space. VAEs consist of an encoder network that maps input data to a latent space representation and a decoder network that reconstructs the input data from the latent space representation. Unlike traditional autoencoders, VAEs learn a probabilistic distribution over the latent space, allowing for the generation of new samples by sampling from this distribution. VAEs are particularly useful for tasks such as image generation, data compression, and representational learning. Recurrent neural networks or RNNs and transformers. Recurrent neural networks and transformers are widely used architectures for sequence generation tasks such as text generation, music generation, and video frame prediction. RNNs, especially variants like long short term memory or LSTM and gated recurrent unit or GRU, are well suited for processing sequential data due to their ability to capture temporal dependencies. Transformers, on the other hand, rely on self attention mechanisms to capture global dependencies in the input sequence, making them highly parallelizable and efficient for long range sequence modeling. Both RNNs and transformers have been applied to various generative tasks, with transformers gaining popularity in recent years due to their superior performance and scalability. Each type of generative AI has its strengths and weaknesses, and the choice of model depends on the specific task and dataset characteristics. By understanding the principles and capabilities of different generative models, practitioners can choose the most appropriate approach for their applications and explore the rich possibilities of generative AI. Applications of generative AI. The first one we look at is image generation. Generative AI has enabled the creation of realistic images, opening up new possibilities in various fields such as art, design, and entertainment. Image generation models like generative adversarial networks GANs can produce high resolution images that resembles photographs of real scenes, objects, and people. These models have been used to generate artwork, create virtual environments for games and simulations, and even generate photorealistic images of non existent objects or creatures. Additionally, generative AI can be used for image editing and manipulation, allowing users to alter and transform images in creative ways. Text generation. Text generation is another prominent application of generative AI, with models capable of producing human like text in various styles and genres. Language models such as OpenAI's GPT series and recurrent neural networks RNNs can generate coherent and contextually relevant text based on input prompts or seed text. These models have been used for tasks such as article generation, dialogue generation, story writing, and poetry generation. Text generation can also be combined with natural language processing techniques for applications like chatbots, virtual assistants, and content generation for social media and marketing. Music generation. Generative AI has also made significant strides in the field of music generation, enabling the creation of original compositions and melodies. Models like variational autoencoders or VAEs and recurrent neural networks or RNNs can learn the patterns and structures of music from large data sets of musical compositions and generate new pieces with similar characteristics. Music generation models have been used for composing background music for videos, creating personalized playlists, generating music for video games, and even collaborating with human musicians in creative projects. Additionally, generative AI can be used for music remixing, reharmonization, and style transfer, allowing for exploration of new musical styles and genres. Video generation. Generative AI techniques can also be applied to generate synthetic videos, animations, and visual effects. Models like GANs and variational autoencoders (VAEs) can generate sequences of images that simulate motion and dynamics, allowing for the creation of realistic video clips and animations. Video generation has applications in the fields such as film and animation production, video game development, virtual reality, and augmented reality. Generative AI can be used to generate virtual characters and environments, create special effects and visualizations, and enhance the realism of simulated worlds. Additionally, video generation models can be combined with techniques like style transfer and scene generation to create visually stunning and immersive experiences. Generative AI is transforming creative industries and enabling new forms of artistic expression, storytelling, and entertainment. By harnessing the power of generative models, creators can push the boundaries of imagination and explore new possibilities in image, text, music, and video generation. Challenges in generative AI. First challenge is mode collapse. Mode collapse is common challenge in generative adversarial networks where the generator produces limited variation in generated samples, often converging to a small subset of the target distribution. This results in generated samples that lack diversity and fail to capture the full range of variability present in the training data. Mode collapse can occur due to various factors such as insufficient model capacity, unstable training dynamics, or imbalance between the generator and discriminator networks. Mitigating mode collapse requires careful tuning of hyperparameters, architectural modifications, and training strategies such as mini batch discrimination and feature matching. Next challenge is training instability. Training generative models, especially GANs, can be inherently unstable and prone to convergence issues. GANs require balancing the training of the generator and discriminator networks, which can lead to oscillations and mode hopping during training. Additionally, GAN training is sensitive to hyperparameters such as learning rates, batch sizes, and optimization algorithms, making it challenging to find the right set of parameters from for stable convergence. Training instability can result in poor quality generated samples, slow convergence, or divergence of the model. Techniques such as gradient penalty regularization, spectral normalization, and progressive growing can help stabilize GAN training and improve convergence. Ethical concerns. Generative AI raises ethical concerns related to the misuse and abuse of generated content for malicious purposes such as spreading misinformation, generating deep fakes, or perpetrating fraud and deception. Deepfake technology, in particular, has raised concerns about the manipulation of audiovisual content to create misleading or harmful representations of individuals and events. The widespread availability of generative models and tools for creating synthetic media has made it easier for bad actors to produce convincing fake content that can be used for defamation, propaganda, or impersonation. Addressing these ethical concerns requires a multifaceted approach involving technical solutions like policy interventions and public awareness campaigns to mitigate the risk associated with generative AI and ensure responsible use of AI generated content. Navigating these challenges requires a deep understanding of generative AI algorithms, careful experimentation, and a commitment to ethical principles and responsible AI development practices. By addressing mode collapse, training instability, and ethical concerns, researchers and practitioners can unlock the full potential of generative AI while minimizing the associated risks and negative impacts. Tools and frameworks. First tool that we look at is TensorFlow. TensorFlow is an open source deep learning framework developed by Google Brain. It provides a comprehensive ecosystem for building and training machine learning models, including generative AI models. TensorFlow offers high level APIs like Keras for building and training neural networks, as well as low level API for greater flexibility and control. TensorFlow's extensive documentation, tutorials, and community support make it popular choice for implementing generative models such as GANs, VAEs, and language models. TensorFlow also provides tools for distributed training, model deployment, and optimization, making it suitable for both research and production use cases. PyTorch. PyTorch is another popular deep learning framework known for its flexibility, dynamic computational graph, and ease of use. Developed by Facebook's AI research lab, PyTorch has gained widespread adoption in the research community and industry for building and training neural networks, including generative models. PyTorch's intuitive interface and Pythonic syntax make it easy to prototype and experiment with different architectures and algorithms. PyTorch also provides a rich ecosystem of libraries and tools for tasks such as data loading, model debugging, and visualization. With support for GPU acceleration and distributed training, PyTorch is well suited for training large scale generative models on powerful hardware. GANlib or GANlib. GANlib is a specialized library for implementing and experimenting with generative adversarial networks (GANs). Developed by researchers at leading AI labs, GANlib provides a collection of pre-trained models, evaluation metrics, and training utilities for building and fine-tuning GANs for various tasks such as image generation, image-to-image translation, and style transfer. GANlib's modular architecture and easy-to-use APIs make it a valuable resource for researchers and practitioners interested in exploring the capabilities of GANs and developing state-of-the-art generative models. OpenAI's GPT series. OpenAI's GPT or Generative Pre-trained Transformer series is a family of language models trained on a large-scale text corpora using the transformer architecture. These models, starting with GPT-1 and evolving to GPT-4 now, have achieved remarkable performance on a wide range of natural language processing tasks, including text generation, language understanding, and question answering. OpenAI provides pre trained versions of these models as well as fine tuning tools and APIs for customizing and deploying them for specific applications. The GPT series has been widely adopted in research and industry for tasks such as language generation, conversational AI, and content recommendation. By leveraging these tools and frameworks, developers and researchers can accelerate the development and deployment of generative AI models, explore new research directions, and unlock the full potential of generative AI across various domains and applications. Getting started, let's go over the basics of deep learning. Before diving into generative AI, it's essential to have a solid understanding of the fundamentals of deep learning. This includes concepts such as neural networks, activation functions, backpropagation, optimization algorithms, and regularization techniques. There are plenty of resources available online, including tutorials, books, and courses that cover the basics of deep learning. Popular resources include the Deep Learning Specialization on Coursera, the Deep Learning book by Ian Goodfellow, Joshua Bengio, and Aaron Kurville, and the TensorFlow and PyTorch documentation. Next, you probably want to do is study generative models. To get started with generative AI, it's important to study the different types of generative models, including generative adversarial networks (GANs), variational autoencoders (VAEs), and sequence generation models like recurrent neural networks (RNNs) and transformers. Understanding the principles behind each type of generative model, how they work, and their strengths and weaknesses will help you choose the most appropriate model for your specific task or application. There are numerous tutorials, papers, and online courses available that cover the theory and implementation of generative models. Experiment with frameworks. Once you have a solid understanding of deep learning and generative models, it's time to start experimenting with frameworks like TensorFlow and PyTorch. These frameworks provide powerful tools and APIs for building and training generative models, as well as utilities for data loading, visualization, and evaluation. Start by implementing simple generative models like simple GANs or VAEs and gradually move on to more complex architectures and tasks. Experiment with different hyperparameters, architectures, and training strategies to gain intuition and hands on experience with generative AI. Explore applications. As you gain proficiency with generative AI techniques and frameworks, explore different applications and use cases across various domains such as image generation, text generation, music generation, and video generation. Start with small projects and gradually work your way up to more ambitious projects as you become more comfortable with the tools and techniques. Collaborate with other researchers and practitioners, participate in online forums and communities, and stay up to date with the latest research and advancements in generative AI to continue learning and expanding your skills. By following these above steps and engaging in continuous learning and experimentation, you can embark on a rewarding journey into the fascinating world of generative AI and unleash your creativity to create novel and impactful solutions across a wide range of domains and applications. Our journey through the realm of generative AI has been both illuminating and exhilarating. We have traversed the landscape of artificial intelligence, exploring the myriad ways in which machines can generate new and original content across diverse domains, from creating photorealistic images and composing music to generating text and synthesizing videos. The possibilities of generative AI are truly awe inspiring. Throughout this crash course, we have gained a deep understanding of the principles and techniques behind generative AI. We have learned about the different types of generative models, including generative adversarial networks (GANs), variational autoencoders (VAEs), and recurrent neural networks and transformers. We have explored their strengths, weaknesses, and applications, gaining insights into how they can be applied to solve real world problems and drive innovation. We have also grappled with the challenges and ethical considerations inherent in generative AI, from mode collapse and training instability to concerns about the misuse of AI generated content. we have confronted these issues head on, discussing strategies for mitigating risk and promoting responsible AI development practices. As we continue to push the boundaries of AI driven creativity and innovation, it's imperative that we do so with integrity and foresight, ensuring that our advancements benefit society as a whole. But our journey doesn't end here. In fact, it's just the beginning. Generative AI is a rapidly evolving field with new breakthroughs and discoveries emerging every day. As we move forward, it's essential that we stay curious, open minded, and committed to lifelong learning. Whether you are a seasoned AI practitioner or a curious beginner, there's always more to explore, more to discover, and more to create. So let's continue to push the boundaries of what's possible with generative AI. Let's harness the power of technology to unleash our creativity and imagination, to solve the world's most pressing challenges, and to build a better future for all. Together, we can shape a world where AI driven innovation enriches our life, inspires our mind, and brings us closer together as a global community. Thank you for joining us on this incredible journey through the world of generative AI. May your future endeavors be filled with creativity, discovery, and endless possibilities. Farewell until we meet again in the boundless expanse of AI driven imagination.